Good afternoon, friends, and welcome again to another session of Mathematics Class 12. Today, we will be dealing with a chapter which is very important for the mathematics part because it is one of the most important topics which is to be covered, which is the differential equations. As you can see, we will be doing differential equations, but along with differential equations, I would suggest you to please follow the integration chapter because it is completely linked with the differential equation. So please follow the integration chapter of the things which I have uploaded. That will help you to solve differential equations. Okay, so this is Parijat sir classes, and please like, share and subscribe my channel so that I can make more and more videos for you as much as possible. So without wasting time, let us move ahead with the differential equations. Okay, so first thing what we have to see, that is the order of a differential equation. What is order of a differential equation? The order of a differential equation is that the maximum times which you have integrated. See, I have integrated here 2 times. This is integration 1 time. This is integration 2 times. So the order is 2. Order is 2. And here I have integrated 3 times. Here it is only 1 time integration I have done. Only 1 time integration I have done. Here I have done 3 times. So order of the differentiation is of this equation is 3. Now what is degree of the differential equation? The degree of the differential equation is the highest differentiation which you have done, its power. Okay, the highest differentiation which you have done, its power. So highest differentiation I have done is d cube. 3 times I have done differentiation here and its power is 1, so that is called the degree. Here highest differentiation I have done is this and its power is 2, so the degree is 2. Okay, order is 3. Order means how much times you have done the differentiation? 3 times. So that is order. Degree means what is the power of the maximum number of times you have done. Here the order of the differential equation which we have to find, or the degree. So let's see how to do that. We have to create a proper order of proper equation in order to find the degree or the order. So separating this and now squaring both sides, we are getting this. Okay, so now we see that the maximum number of times we have done differentiation is only 1 time. Only 1 time we have done, and its power maximum is 2. So the degree is 2 and order is 1. Degree is 2 and the order is done. Order is the maximum number of times you have done, which is only 1 time I have done, and the degree is the power of the maximum number of times which we have done, that is 2. Now here let us find the degree of this equation. So first of all, what we are doing, we are squaring both sides. So this becomes this. Now as you can see, the order of the degree of the equation is the degree is the maximum number of times which you have done. We have done the maximum number of times is 2 times. So the order is 2. Order is 2. And the power of this maximum number of times is 2. So the degree is also 2. Similarly, from here, if I separate the dy by dx, that means I have done only 1 time differentiation. So the order is 1 and its power is also 1. So the degree is also 1. Clear? Next, from this equation, p is given as dy by dx. So let us put the value of p dy by dx. We'll put the value of p dy by dx whole square. Now squaring both sides, we are getting this is a square plus b square. Okay, and then we have done this. So this will be, I have missed one term here. I have missed one term, that is minus 2ab. This I have mixed. Okay, so what is from here? We see that if I take the dy by dx common, we are getting this. So the maximum number of times I have done differentiation is one time, that is the order is 1, and the power of that maximum times is 2, so the degree is 2. In this equation, the maximum number of time differentiation done is 2, so the order is 2, and its power is 2, so the degree is also 2. Next sum, as we can see, formation of a differential equation. We have to form the differential equation. So see, this is the differential equation. This is the equation whose differential equation I have to make. So please note one thing. You will first check how many constant terms are there. Only one constant term. So you have to differentiate only one time. If you have two constant terms, you have to differentiate twice. If you have three constant terms, you have to differentiate thrice. Okay, so please note here, there is only one constant term, so differentiation is also 1. So let us differentiate this equation. So c, 2y plus c. Now y will be dy by dx, and this part is 3x square. So from here we are dividing this second equation by the first equation, and we are seeing that many things are cutting out. So all the constant terms from here, this is, after this we get this. So from here separating the c. Now when we separate the c, we will put back the c here in the equation. We are replacing the c. So this was c minus y, and this was the y plus c whole square is x cube. So these things cut out, we get this, and now writing it in a proper way, this is our differential equation. You have to separate the constant term by doing differentiation and replace it in the original equation. That is our target. Clear? Next is, so see here again they have given, this is an equation. I have to find the differential equation of this. So only one constant term, so I have to differentiate only one time. So let us differentiate this. We are getting this. So from there we are getting this is the equation, and now dividing the second equation by the first equation. This is our equation number 1. So we are dividing 2 divided by 1. So we are getting this. So now from here we are getting this. So separated the c, as I told you that you have to separate the constant term and replace it in the original equation in place of c and c. Now I will put this value. So this was y equal to, it was c, so this is our c, x minus c whole square. Okay, so now simplifying it, basically, so this x and x will cut, so it remains this, so it becomes this, squaring both sides, and now we are doing dy by dx, so it will come to thrice times. So simplify this and you will get this equation. So this is our differential equations answer. Clear? Let's see the next question. So the next question says, form the differential equation, and this is our equation. they are telling they are two constant terms, so we have to go up to second type differentiation. Okay, so first doing the differentiation first time, y is dy by dx, cos x plus b is minus sin x plus b, and x plus b will be only 1, so it is this. Now differentiating it twice, this becomes d2y by dx2, this becomes cos x plus b minus, and now see this is our y, so this becomes our differential equation. That means in your differential equation there should not be any constant terms, any constant term should not be there. Next is using this we have to make a differential equation, and please note a and c are constants, so we have to go up to d2y by dx2. Okay, so here is the first differentiation we have done of y equal to a sin bx plus c. It becomes a cos bx plus c, and bx plus c is b, so it becomes this. And now differentiating it again, cos bx plus c is minus sin bx plus c, and bx plus c is b, so it becomes this. And we can watch from here that this part is actually y, so separating, so putting the value of y, we are getting this term. So see, a and c were constant, which is not here, so this is our differential equation. Next we have to make a differential equation of this. Here they are telling a and b are constant, two constants, so we have to go up to second order differentiation. Okay, so first we are doing the differentiating the first equation, we are getting this is 2y dy by dx, and my b square minus x square, so b square is constant 0, minus x square is minus 2x, so 2 and 2 cuts, so this comes, so this is our first constant we got. Okay, so what we can do is that we can again differentiate this term, differentiating the first equation, so this is u into v form, u into v form, so u differentiating the second term plus v differentiating the first term, and minus ax is minus a, so putting the value of a here, so we got this term. And now in this equation, see, there is no constant term, so this is our differential equation. Clear? Next, this is the equation given to us, so we see that here m and a are constant, so we have to do up to second order differentiation. So it is 2y dy by dx, and a square minus x square, it becomes minus 2x, and so 2 and 2 will cut, so it becomes this, separating the first constant from here, and now differentiating this term again, so it is u into v form. Okay, so which is, this is the v du by dx plus u dv by dx is minus x. Now putting back the value of m, we are getting the differential equation. Clear? Let's see the next sum, friends. Okay, so the next sum says that form the differential equation of all the circles touching the x-axis at the origin. That means circles will touch the x-axis at the origin. That means it can be this or it can be this shape. Okay, so suppose this is 0 comma b, so the radius 0 comma a, so the radius of the circle is a, Okay, so let us take, we know that equation of a circle passing through h comma k, we know the equation of a circle having center h and k is given as this. Okay, so here h is 0 and k is a and r is also a. So now this equation becomes this, and now we see that here only there is one constant here, only one constant, which is a. That means I have to differentiate it only one time. So differentiating this becomes 2x, this becomes 2y minus a, and y is dy by dx, and this is 0. Okay, so from here we are separating the y minus a as this, and that is a. So we separated the a, and now we will replace the equation of the this equation. In this equation we will replace back. Okay, so first of all, if I expand this equation, it becomes this. So then a square and a square cuts, so this remains, and now in place of this a, in place of this a, I will replace my value of a. So this comes out to me to be my equation of the circle which is touching the x-axis. Next is equation of all circles touching y-axis and passing through the origin. So how would the figure look? First of all, let me show you how would the figure look. Equation of all circles touching the y-axis. Okay, so touching the y-axis, that means it can be either like this or it can be either like this. This is the y-axis. That means either it can be a comma 0 or minus a comma 0, and the radius is a. Okay, so my x is a and my h is a, my h is a and my k is 0 and my r is a. So using this we put this equation, and now expanding it we get this. So now we differentiate it. X square is 2x, this is minus 2a, this is 2y, dy by dx is 0. So x minus a is this. From there we separate the a is this. Okay, this is a. Now putting the value of a in equation 1, x square minus this, x minus a. So we are getting this equation, and that is our final equation, differential equation of the equation of the circles which touch y-axis and pass through the origin. Next is, as you can see friends, form a differential equation of all the circles of radius r. That means this should be, that means there is a the circle is passing through a comma b and radius r. So the constants are a and b. Okay, so that means we have to differentiate two constants, so we have to differentiate up to second order derivative. So let's see. So differentiating this becomes 2x minus a, differentiating this becomes 2y minus b, and y is dy by dx. Differentiating r will be 0. Okay, so from here what do we get now? Please watch here. We are differentiating this second equation. So please watch here one thing, that is, so we are differentiating this, we have to do 2 times. So x minus a differentiation will be only 1, so 2. Now this is u into v form. So 2 differentiating y minus b will be dy by dx into dy by dx, and now differentiating, keeping y minus b, we have to differentiate dy by dx, which is d2y by dx2 is 0. So from here we can see that I can separate the y minus b. I can separate. Now putting the y minus b in equation, this second equation, in the equation 2, we get this. Okay, in the second equation, if I put y minus b, I am getting this equation. So from there we are separating the x. From here we are separating the x minus a. Now x minus a separated, and y minus b separated. So we will put it in this equation. In this equation we will put it the x minus a and the y minus b, and we will get the differential equation of our question. Next is, show that the differential equation represents the family of parabolas having their axis of symmetry coincident with the axis. So see, this is a parabola. They are having axis of symmetry with the x-axis. So this is the axis of the symmetry which can cut the parabola. So the parabola should look like this. Okay, vertex b comma 0. So our equation of the parabola would look like this. If you know the parabola's equation, it is y minus h whole square, y minus k whole square equal to 4a x minus h whole square. Here x is b and k is 0. So putting this, we get this. Now here how many constant terms are there? So as you can see, there are two constant terms, a and b. So we have to differentiate up to the second order differentiation. So now differentiating this, we get 2y dy by dx, and this becomes 4a. So now again differentiating it, we have to do twice. So this is u into v form, applying the u into v form. So now we are getting this. So this is actually y1 square, and this is y into y2. So that means this is our differential equation which we have to prove. Similarly, form the differential equation of the family of parabolas having vertex at the origin. This is the vertex at the origin and along positive y-axis. So see, this is along positive y-axis. So the focus is at 0 comma a. So this is our differential equation of a parabola having axis of symmetry, the y-axis. So here only one constant is there, a. So we have to differentiate only one time. So 2x, and this is 4a dy by dx. Separating the a, we separated a and replacing back in the equation and simplifying it. This is our equation. Next is form the differential equation of the ellipse. So this is the ellipse having foci on y-axis and center at origin. So see how to draw it. Foci on the y-axis. These are the foci on the y-axis. So let this length be b and this length be a. So equation of the ellipse is written like this. So we see here that there are two constant terms here. There are two constant terms, a and b. So we have to differentiate up to the second order. So first differentiation we are doing is 2x by a square plus 2y dy by dx by b square. Two cuts, we get this, and now again differentiating it. So this will become only 1 by a square. This is u into v form. Okay, so differentiating y will be dy by dx into dy by dx is dy by dx whole square. And now keeping keeping y, we have to do dy by dx, which is d2y by dx2. Now multiplying the third equation, this is the third equation, by x, what do we get? We get x by a square plus x of this plus x into this. Clear? So now this is fourth equation, so this minus the second equation, so this x by a square will cut out, so this will remain. Clear? This will remain. So now we will do is this is equal to this, so this whole equation should be equal to 0, and which is the differential equation, because b cannot be 0. You see, b cannot be 0, so this has to be 0. So this is our differential equation. Next, see friends, show that the differential, this is our equation, and the answer is coming this. So here we see that only one constant is there. So differentiating with respect to x, we get this becomes 2x, this becomes 2y dy by dx. Okay, this becomes 2 c x square plus y square, and now x square will be 2x and y square will be 2y dx, 2y dy by dx. Cutting out the common 2 from here, 2, 2 and 2 cuts, so this remains. So value of the c is separated. Putting the c in the original equation, we get this equation. Okay, and now we have to simplify it. This will cut. This part is multiplied with this. Opening up the brackets, see, we are just simplifying them, whatever things cuts out, opening out the brackets and simplifying, then we get the answer of this differential equation. Please watch one thing, that is opening up the bracket and simplifying. Now simply simplifying it, we will get the answer of this. We'll get this answer. Next, see, this is the equation given. A and B are constant, so there are two constant. That means we have to do up to the second order differentiation. So first differentiating x becomes 1, y becomes dy by dx. From there we are now multiplying this equation by x, this is into x, so we are getting this, and now this minus this, if I do, we will get this. So 1 by b of this is minus 1. Now again differentiating it, because we have to do up to second order, so this is u into v form. Okay, so x is 1, so only dy by dx, and now keeping x, dy by dx is d2y by dx2, and this y is dy by dx. So we are getting this, so basically this and this will cut, so we get this. Now b cannot be 0, that means this has to be 0, so this is our differential equation. Next, see, this is our this is the equation, and I have to find the differential equation. Okay, so first let us do the dy by dx of this, which we get this. Now, so this we got. Now y 0, that means in place of x put 0 and in place of y put minus 1. So here in place of, so taking this equation, in place of x we'll put 0 and in place of y we'll put, so what we are getting, y0 as minus 1. So we see that we got the equation. Next is show that this equation is the solution of this. That means the differential equation is coming this. So let us first do the differentiation of this. This is the first time and this is the second time. So third time if I differentiate it, definitely I will get 0. Okay. Now we have to prove that y0 is coming 1. That means in place of x, if I put 0, answer should come 1. So in this one, in place of x, if I put 0, yes, I am getting 1. Y double dash, in the y double dash, if I put x as 0, answer should come 2. So let's check. This is the y double dash, differentiating it. So if I put 0, that means y double dash is coming 2. At whatever value of x you put, it comes 2. So this is correct. And y triple dash, in place of y triple dash, in place of x, if you put 0, you will get 2. So let us see. In the y triple dash, this is a triple dash. In the triple dash, we are getting 0. Okay. This should be the thing. So this is the differential equation, the first part of the differential equation, and I would suggest you to please go through it nicely and practice with me so that you can understand it properly. So this was the first part. This was the part 1 of the differential equations we have done. We'll come up with more and more parts, but please keep watching Parijat sir classes and like, share and subscribe, do, and keep waiting for the second part of the differential equation, so that follow part by part. After this another part will come and then another part will come. So keep following the parts so then you will learn the different types of differential equation. Okay. So till then, it's goodbye from my side and thank you.